So thanks everybody for joining. We'll get started now. My name is Neil Elliott. I am Director Emeritus at ACEEE, and I will be your host this afternoon for this webinar. We're really excited to have you join us. We've assembled what I think is an excellent panel. I think it'll be very interesting. Wanted to go over a couple of housekeeping details before we get started. For those of you who may not be completely familiar with Zoom, if you'll look down in the bottom tray, there'll be a number of options down there that we'll be using today during the webinar. This webinar, because of the number of attendees, we're not going to be able to take verbal questions from the participants. So we would ask that you use the Q&A feature, which is located to the right in the tool tray at the bottom of your screen. That will enable you to pose questions. You can pose them to the panel or into an individual speaker. My colleagues, Andrew Hoffmeister and Pavitra Srinivasan, will be with me tracking those questions. And when we get to the session, I will go ahead and pose those questions to the speakers. The speakers may also want to actually respond back through the Q&A feature. If you encounter technical issues, I would encourage you to use the chat feature to notify us, and our producer for today, Nick Roper, will attempt to address those issues. Just also on the bottom tray, there's a poll feature, and we'll be doing 2 polls during the webinar, and I will announce them. One's just at the start of the panel discussion, and the second is just before the final wrap up with our Industrial Program Director, Ed Ryder. To be efficient, I'm going to pass on providing detailed bios for each of the folks. There is we already have the bios up on the website. I put that in the chat. I'll put that in the Q&A here in a minute. This webinar will be recorded and be made available to you for streaming in the next few days. And at that time, the speaker slides will also be made available. At this point, I'd like to go ahead and introduce you to Ed Ryder, who's the ACEEE Industrial Program Director, for a welcome and an overview of the scope of this one. Ed?
Okay, well, thanks, Neil. Welcome, everyone, to this webinar focusing on embodied carbon. As you probably know, this is a topic that has gotten a lot of interest recently. Companies are setting science-based targets. The customers are asking for low embodied carbon materials. The White House has an executive order on buy clean, yet the machinery to put embodied carbon on materials, tracking that carbon throughout the supply chain and engaging multiple stakeholders is still something that needs some work. We hope in this webinar today to set the stage for expanded engagement, to use this webinar as a starting point for additional information and to spark discussion. With that, I'll look forward to the discussion and also thank colleagues such as Pavitra Srinivasan and Neil for their help in putting this webinar together.
Thanks so much, Ed. I would now like to turn things over to our Senior Director for Research at ACEEE, Dr. Nora Wang Esram, who's going to talk about some research that ACEEE has recently published on embodied carbon.
Well, thanks, Neil, and welcome joining us today. I'm an architect by training. Today, I would like to set up the stage for our discussion by sharing the gap analysis we did last December. Nick, if you can pull up the slides, that would be great. So As aggressive building energy codes push towards net zero building operation or net zero energy operations, and we need to pursue corresponding efforts to reduce embodied carbon from building construction materials so we can achieve the building sector's decarbonization goal. A study published in 2016 looking at 90 case studies and shows that, for the low energy buildings, the embodied carbon accounted for 30 to 60% of total life cycle carbon. If we're talking about net zero energy buildings, that number goes up to 75 or even 100%. We have a lot of current efforts in setting up the critical momentum, such as voluntary rating system, bike lane policies, or voluntary reporting or disclosure. Building codes and standards are an effective policy approach to accelerate the shift to low embodied carbon materials by influencing the general building practice. Well, the question is, are we ready to introduce embodied carbon into codes and standards? And do we have adequate knowledge infrastructure to support implementation of such new standards? So our study aimed to, having that conversation and trying to look at what we have today. Before I share our findings, I would like to just explain a few key concepts, just in case some of you are unfamiliar with life cycle assessment or embodied carbon. So as you can see on this slide, first of all, embodied carbon quantification is derived from so-called life cycle assessment in buildings, or LCA. It's based on global warming potential output, and LCA has many other inputs, and GWP is one of them. And GWP measures a multitude of greenhouse gas emissions in CO2 equivalents. It's measured in unit of metric ton CO2e. In buildings, we can talk about a kilogram CO2e per square meter, for example, as equivalent of kBTU per square foot as we talk about energy. When LCA is applied in buildings and constructions, there are 4 levels of assessment: at the material level, product level, building or industrial level. And then the product level includes building components, systems, and assemblies. And then on the right-hand side, you see the so-called LCI, life cycle inventory data, that feeds into the LCA analysis as the primary inputs for us to conduct LCA assessment. Next slide, please. So this one, I just want to explain quickly, what we're talking about embodied carbon. Any buildings in carbon emission include 2 broad categories: life cycle embodied carbon and operational carbon. The life cycle embodied carbon is the so-called cradle to grave carbon emission. It includes stage A, B, C, and sometimes D, depending on how we quantify that. And then the operational carbon is composed of the carbon emission generated from the B6 stage, which is the energy used to condition or power a building. Sometimes you also heard so-called the upfront carbon, include the manufacturing and construction process. Cradle to gate is A1 to A3. If we add construction and transportation, you get this cradle to side, which is A1 to A5. Next slide. How do we assess knowledge infrastructure? We focus on three critical components: databases, standards and methodologies, as well as tools. We also want to know if there are transparent, credible processes to govern these databases or tool development. So with all of this question in mind, we dive into literature. Next slide. On this slide, you can see we found over 8,000 relevant publications from 2010 to 2021. Those were through the research, through the literature search on the Science Direct website using keywords such as embodied carbon in buildings. And after multiple rounds of screening, we were able to focus on 44 very relevant articles. And then in addition to that, we look at the tools and databases that are being popularly used in the United States or Canada. Next slide. So this is a busy slide. I don't think we have time to dive into it. If you're interested, I encourage you to download our report. Overall, this is a snapshot of the databases that we reviewed. I would say comprehensive embodied carbon data exists to evaluate all life cycle stages. I want to highlight a few things. If you can, focus on the column labeled as number 3, the size of a database, you can see it varies from hundred thousands of data sets to a few hundred data sets. So databases are not equal. If you look at the column label number 5, 5 out of the 10 reviewed databases use primary data sources, and the others use secondary data sources. Look at the one label number 1, cost of use. The good news is that 8 are free for users and 2 developers. And overall, the main issue we found was data standardization and transparency need to be improved. Not all databases are regularly maintained, nor do they consistently include documentation of their data sources or methodologies. It took us quite a lot of effort to dig into their documentation. Next slide. So this one is again a snapshot of the tool comparison of the 7 popular tools we look at. It doesn't include all of the tools, but the major ones we could find. If you look at the column labeled number 3, database uses, you'll find 3 out of the 7 tools are based on Gabi database. The next column to the right and shows 3 out of the 7 tools provide whole building level assessment. The rest are at material or product level. Overall, we feel that transparency and quality assurance of the tools need to be improved. There are 2 studies to compare these tools, one in Italy, the other is in Finland. And then they enter the same amount of inputs exact into 2 different tools and generate different results. The discrepancy in the embodied carbon, it's between 10% to 15%. It may not sound like a lot, but actually it leads to very different design solutions that may have downstream consequential impacts on the users and the buildings. So overall, we didn't find any standard testing procedures to compare or benchmark the result from these tools. Next slide. So this is a pyramid matrix we put together and trying to quantify the findings from our literature study. We categorized and counted the topics in each article by the knowledge areas. As we mentioned, either method, data, or tool. We also, and then look at their assessment level, material, product, or buildings. The reason you have this pyramid shape because the size of the circle indicates the relevant amount of information needed at each level. On the top, the building level information is more aggregated. That's why you see a relatively smaller cycle. I want to say this metric is by no means trying to quantify the amount of knowledge we have. It's just a way to illustrate, give you a sense of where we have more knowledge, where we have less. And then the percentage shown here in the dark shaded color represent the degree of topic coverage and during our literature study. If you look at horizontally, right, layer by layer going up, you find that the most detailed knowledge we have for embodied carbon resides at a material level or product level, and building level has least amount of information developed. If you look at vertically, of the information we discovered, we have more efforts in tool development, some in methodology or good amounts in methodology, but we have the least amount of effort and being made on data across all levels. Next slide. And dive a little bit deeper. What is the database issues we have observed? And then the first is relevant to the availability of embodied carbon data in the U stage, which is B and C, the end of life stage, if you recall the chart we just showed at the beginning of this presentation. Because in this stage, the embodied carbon are highly dependent on the assessor's assumption of how a building may be used or maintained. That's why the consistent tracking or data collection stop there once the building is constructed. The second issue we find is within the pre-use stage, stage A. If you remember, we have cradle to gate and we have cradle to site. We have more knowledge during the manufacturing process, A1 to A3. We have less information published for transportation and construction. So the whole stage is incomplete. And then the third issue is about the missing guidelines for supply chain specific or facility-specific data collection. When you have to use industrial average data that discourage the manufacturings from produce low embodied carbon products at a specific level or within a specific product or services. And then the last issue is around the lack of consensus how we should integrate the benefits of reuse, recycling, and recovery of a building that's towards the end of service life. We don't have a good way to evaluate, rather we should construct a new building versus we should retrofit an existing building. Next slide. So overall, very few activities are focused on data collection, on embodied carbon or energy at the whole building, and lack operational energy. We have abundant data in telling us the energy use of a variety of building types. And embodied carbon or energy has very few benchmarking references. The most comprehensive assessment we have was back in 1979. The recent effort includes a benchmarking study conducted by Carbon Leadership Forum back in 2017. And then they put together a database of over 1,000 LCA studies, and half of them are buildings in the United States. It sounds a lot, however, once you dive into specific building type, location, construction type, and all of a sudden you really do not have statistically significant results to provide either benchmarking or goal setting. So creating a quantitative benchmarking data set, we believe, is the first step to create a meaningful pathway to regulate embodied carbon emissions in buildings. And if we have such a data set, we're able to develop a baseline or target setting for building embodied carbon. Next slide. This is my last one. So it summarizes the 6 key findings and our recommendations. There's a URL, you can download our report as well as a policy brief. As a closing remark, I would like to say we need everybody's participation to fill in this knowledge gap, not only the building stakeholders, but also the manufacturers. With that, I'm going to turn back to Neil.
Thank you so much, Nora. We're going to move now to a series of brief presentations from several stakeholders representing various parts of the industry. And we're going to start with Richard Bowen, who is with the Portland Cement Association. And again, the website for this webinar has everybody's bios if you want to look at those. Richard?
Thanks very much, Neil. And Nick, if you could go to my first slide. There we go. So the cement industry, obviously we produce cement, but unfortunately that process also produces CO2. I've got 2 equations up there to keep it really basic. The initial reaction we need takes calcium carbonate and drives off CO2. If we don't have that initial reaction, we can't manufacture cement. Right now in the US, that accounts for 60% of our CO2 emissions at the cement plant level. Now to get that reaction to occur, we need very high temperatures, about 2,800 degrees Fahrenheit, 1,500 degrees C. To get those very high temperatures requires combustion. And that's the second equation I've shown. That produces 40% of our CO2 emissions. And by the way, calcium carbonate, folks, if you've ever popped an antacid or cracked an eggshell, that's calcium carbonate. So is limestone. I put the numbers down there in terms of what the US cement industry's contribution is. Next slide, please. So at the cement plant, we make an intermediate product called clinker. You'll never see it unless you actually visit a cement plant. But the point is, clinker is the key ingredient to cement. Cement, when it's mixed with water, aggregates, other materials, is a key ingredient in concrete. Concrete, folks, so you walk on a concrete sidewalk. Your flight lands on a concrete runway. And concrete is the universal building material in construction in the built environment. There's not a project in the world that doesn't use some amount of concrete in the built environment. And then finally, a lot of people don't realize that concrete also is a CO2 sink. There is a chemical reaction that occurs naturally, and concrete will absorb about 10% of the CO2 emissions generated during the manufacture and transportation of both cement and concrete. The key takeaway right here, though, is that we can't reach carbon neutrality in any one of these links. We need all of these links. Now, even if we had carbon capture today, that will capture a lot of CO2 at a cement plant, but it won't capture all of it. So we have a roadmap to carbon neutrality focused on this value chain. And a lot of it ties into what Nora was just saying about getting everybody. So we can't control some of the downstream parts of our value chain, but we can influence them by showing them, hey, here are things you can do to take advantage of it and help all of us reach carbon neutrality. And by the way, we've got like a 70-page document available online. You can go into a lot more detail there. Next slide, please. I mentioned a lot of people aren't familiar with this, but there is a process called carbonation. It's a naturally occurring process. One of the best examples I can point to is, most people don't realize, but the Pentagon is almost 80 years old. Again, it's absorbing 10%. This is a very long-term process. The other thing that I want to leave folks with is that, again, hearkening back to what Nora said, you know, when you look at the entire built environment, you really have to take a very holistic approach. Why? Because think about it. An example, the Empire State Building is almost 100 years old, folks. Now, if you look at just the embodied carbon content of the materials, okay, but now think about all the energy that went in, or that goes into the Empire State Building for elevators, escalators, boilers, chillers, fans, compressors, pumps, air handling equipment, workstations, display screens, and so forth. It's huge. So you have to take a holistic approach. And with that, I'm going to just stop right there because I know we've got other panelists and I want to make sure everybody has plenty of time and that we have time for questions. Thanks so much, Neil. Appreciate it.
Rick, thank you again. And I'd like to turn now to another important product, which is insulation. And we have Curt Rich with the North American Insulation Manufacturers Association Insulation Institute, who's going to talk a little bit about that product.
Great, thank you, Neil, and thank you, Ed and Nora, the ACEEE team. The work you're doing on this topic is, I think, very important as well as timely. Again, my name is Curt Rich. I lead the North American Insulation Manufacturers Association. That's the trade association for the fiberglass, rock, and slag wool insulation industry in the US and Canada. You know, insulation, our value proposition is reducing building energy consumption. So in a way, we've been, as an industry, very focused on decarbonization for the better part of a century. More recently, insulation manufacturers have been leaders in the development of environmental product declarations. That's largely in response to demand by the design build community. And so as you look at building material products and go to any of those sites Nora had listed, you will see a proliferation of insulation EPDs on those sites. And then, like all of the industries who will speak here today, we all support decarbonization policies, and we all want to be engaged in the shaping of those policies. I want to focus my comments today on kind of the two principal policy drivers for decarbonization, and that is building energy codes and then buy clean policies. The first is building energy codes. As Nora had talked a little bit about in her presentation, a future decarbonization code. And I think when people talk about driving decarbonization policies into the building code, they are typically implying about bringing in by clean policies into those codes, or else electrification policies. And I just want to remind folks on the call that really the foundation of a decarbonization building code is the building envelope. If you have a robust building envelope, you use less energy. That means smaller HVAC systems using less refrigerants. It means a smaller generation footprint. And it means over the life of that building, energy savings and improved management of peak heating and cooling loads. For those energy efficiency code geeks on the webinar today, you know that there has been an ongoing debate over the last several code cycles over envelope trade-offs. Builders and the home builder lobby, they argue for less stringent energy efficient envelopes if they use more efficient HVAC systems. More recently, the solar industry is very active in code development talks, and they argue for less efficient envelopes if only builders if they're able to use solar panels and battery storage. I think those priorities are pretty misplaced. Really, our goal as we try to decarbonize our building stock should be as a foundation to build the most robust building envelope that we possibly can. Only then can those other policies, including electrification, follow on and help us reach our goal of building decarbonization. Moving now to just a couple of comments on buy clean policies. And again, I just really want to echo a number of the findings that Nora and the ACEEE team just reported on with respect to EPDs. These are obviously the primary mechanism for compliance, but I think that there is a case to be made that we need more active federal government intervention to make sure that the LCAs and the EPDs that we use to drive decarbonization policies result in a workable framework that industry can trust, that they know are accurate, and the gaming is eliminated, and that is our principal concern. And what we see in the market right now is just that at a very basic level, the inability to rely on EPDs in all cases for a true apples to apples comparison between like products. And as we go forward and adopt buy clean policies, we need to make sure that those comparisons are achievable. We need to make sure that the preparers of EPDs are held accountable, that they are relying and integrating accurate data. We need to make sure that geographic considerations, gate to market, are considered in the development of EPDs. And we need a framework for both tracking and policing the EPDs as they proliferate to again make sure that they're accurate and can be relied on, and that this nascent industry is really above board. And so, I think industry needs to be at the table to get the rules right. I think as an illustration of what happens when industry is not at the table, you only need to look at California. In 2017, California enacted the first Buy Clean law in the United States. And in that law, they required EPDs on government contracts for structural steel, concrete reinforcing steel, flat glass, and mineral wool board insulation. Now you might ask yourself, why mineral wool board insulation? This product competes with a half a dozen other insulation products in the market, including XPS, EPS, polyiso board, fiberglass board. There are no California manufacturers of mineral wool insulation board that would draw the attention of the assembly. And in fact, mineral wool insulation board only has a market share of about 2% of the market. So as this first Buy Clean law gets off the ground, when it comes to insulation, how is that law inviting any sort of comparison between insulation products competing for the same application? It's a complete mystery to me. But rest assured, the California Assembly is going to fix this. So there's legislation now pending where they propose expanding the Buy Clean law to include all insulation products. Only under the terms of that legislation, mineral wool board insulation would require facility-specific EPDs, while all other insulation products would require product-specific EPDs. Now, I raise this not to complain about California or about government going awry, but I raise it to make the argument that as we start to put decarbonization policies in place, the difference between success and failure it lies in the competency of these policies. We need to have, again, equivalent comparison between like products that are competing in the same market for the same application. And what we're seeing in California is not the roadmap for how to get this right. And that's why I think at the federal level, there's really an opportunity with both the government as well as stakeholders to sit down and develop a framework that promotes transparency, promotes accurate measurement, promotes the same treatment for all products that compete with each other, and gives us a regulatory framework that's above reproach and isn't seen as a vehicle simply for greenwashing or for gaming by unscrupulous actors in the marketplace. So with that, I will get off my high horse and turn the mic back over and look forward to the conversation. Thanks, Neil.
Thanks, Curt. Appreciate it very much. We're now going to turn to another key construction product, wood, and for that, we're going to have Rachel Jamison with the American Wood Council. Rachel?
Good afternoon, good morning, wherever you are. If we could have Nick please pull up my slides. I want to start by extending my sincerest thanks to ACEEE for including the American Wood Council in today's presentation. Already with what Curt and Rick have shared, there is a lot of commonality in we're needing holistically. Next slide. A little bit about American Wood Council. Oops. Hold on. Thank you. So we are the nationally recognized technical authority and advocate for the US wood industry. We represent approximately 86% of all of wood products produced in the United States and supply 450,000 men and women good paying manufacturing jobs. Next slide. So in the space of embodied carbon, I'm going to talk about essentially some of our areas of emphasis. First of all, the wood products industry recognizes that climate change is one of the most compelling and important issues of our time, and that we all need to come together and work together to address it. We have essentially 4 main areas that we are focusing our efforts on to address embodied carbon that get at a lot of what Curt and Nora and Rick had talked about, both from the standpoint of data harmonization and ensuring that apples to apples comparisons are available, and also from the standpoint of methodological approach and statistically significant data sets. One of the sort of mottos that we've taken on of late is to operate with radical transparency. If there are questions that folks have about our industry, we are going to do absolutely everything that we can to get the information that you need. And pardon my dog in the background. We are in the process of developing an industry-wide EPD database. We're collecting information from all of our members and may broaden it beyond if necessary. Hold on for just 1 second. I am so sorry. So the database should be representative of that 86% by volume that I spoke of earlier. Data transparency and consistency, as Nora alluded to, is critical, and that research on how the data, once collected, is treated by the varying systems that push out either that account for material comparisons is critical. I also think that there hasn't been enough, and it alludes to some of, Curt, what you were talking about, and in the next bullet, thoughtful engagement on policy. There has been an EPD approach to both the systems and to policies, where I think true and broader decarbonization could come from whole building life cycle assessment at the design phase. So that's another area that AWC is really focused on, is both collecting data for EPDs, but also really working to advocate for whole building life cycle approaches to be taken. And this gets to Rick's and Nora also alluded to, where we're currently failing is on recognizing the stored carbon benefits of building materials. Wood by volume is 50% carbon. So as Nora went through the ISO process for accounting for embodied carbon, what is woefully missing is any accounting for stored carbon in the buildings, recognizing that buildings are long-lived, hopefully products, and as such, keep that carbon for many, many years. The second area that we're really looking to focus on is thoughtful policy, and this too has been alluded to. We need to be at the table. I think it is something we can all agree on, that we all want to see decarbonization of the built environment, and the industries that produce the materials for the built environment are committed to reducing and doing our part. We need to be at the table. We need to be able to inform what is feasible, to inform and work together on buy clean policies, Curt, that you were talking about, that are actually feasible for all of us. I think we all want to step forward and be wildly supportive of buy clean efforts. Unfortunately, the lack of engagement has been significant. And so we are hoping for a more robust engagement so that everybody from NGOs to industry to policymakers can come together and agree on a path forward. The next area of focus is really collaborating with the forest sector. In the US, our forest stocks are being maintained and increasing actually. That being said, we want to make sure that we have fiber sourcing data. A lot of questions come up about where is the wood coming from, and those are very rational and reasonable questions. And we have numbers of projects underway to answer those questions. Finally, we want to really educate broadly, work with LCA tool developers, NGOs, and others to ensure, as others have alluded to, that accurate data is being shared in an apples to apples method, that concerns are identified. And for us, we want to ensure that there are systems in place to describe the unique climate benefits of wood products as they are utilized in the built environment. Next slide, please. One of the unique attributes of wood products is we are a renewable resource. In the US, our forest stocks have been increasing during times of significant, and I'll put a resource in the comments when I'm done speaking that kind of goes deeper into this. But for every 1,000 board feet of wood products, 23 trees are planted. So essentially you have the sequestration that occurs once a tree is planted, pulling CO2 out of the atmosphere, holding that CO2 and pulling in even more through the growth phase, and then essentially storing the CO2 in the long-lived wood product, only to then be again replanted. So it's the only building material that really offers that renewable, that is a renewable resource, and where all phases of the growth and utilization phases provide carbon and climate benefits. And my last slide is for questions. I look forward to hearing your thoughts. Thank you. Thanks, Neil.
Thank you so much, Rachel. And now we're going to switch to the other side of the whole system and hear an engineering perspective on addressing some of the questions about using these materials. And for that, we're going to have Jennifer Goupil from the American Society of Civil Engineers talk a little bit about that. Jennifer.
Thanks, Neil. I'm going to go ahead and just dive right in. So as my slides are getting pulled up, but yes, I am Jennifer Goupil, and I wanted to thank Ed for the invitation. I'm delighted to be here to join this discussion today. I am a structural engineer by training and education, and my current role is to oversee all the codes and standards and technical development and advancement here at SEI. And I know that some of you might be less familiar with our work, and so I just want to take a tiny little minute to explain what it is and what we do. Next slide, please. So the American Society of Civil Engineers is a professional society with more than 150,000 members worldwide. Our mission really is to advance civil engineering and to protect the public health, safety, and welfare through education and advocacy. The purview of civil engineers, as most of you hopefully know, is the entire built environment: roads, bridges, water system, electrical systems, lifelines. And one of the unique specialty disciplines within civil engineering is structural engineering. So over at SEI, it's one of the 9 institutes within ACEEE. We're the premier professional organization for the full practice. Our membership includes more than 30,000 practitioners, consultants, academics, producers, students, and many more that make up the work that we do. We have more than 100 committees working on all kinds of technical advancements and practice areas as well. But I would argue our most impactful work is coming from developing standards that are adopted into the building code, ultimately becoming the legal requirement for building design and construction. There at the bottom of the slide, you see I've placed 3 of our most impactful standards: ASCE 7, 41, and 24. These govern loads and design for all buildings and structures, seismic retrofit and upgrade, as well as flood design and construction. All of these 3 documents are very, robustly developed and timed specifically so that they will align with building code adoptions, and that's what you see there. They will make their way eventually into that document. Okay, next slide, please. So I wanted to talk a little bit about the embodied carbon superheroes in the building sector from my view, working on this challenge, which I thought might be very appropriate for our conversation today. Of course, Nora and some of the others have alluded to the great work at the Carbon Leadership Forum. And I would say Kate Simeon and her team really have created a movement around this in the building sector, really driving change and challenging us to do better. They laid down the challenge for architects, engineers, and MEP, everyone aligned with the building sector. And I would say a group of very forward-thinking experts picked up that challenge. They answered the call and have established the ACEEE 2050 program here within SEI to transform the profession of structural engineering into a net carbon on all projects by 2050. So this army of experts is really driving the awareness for embodied carbon through education and program. And just briefly, I want to talk about two marquee programs that the group is working on. They have established the ACEEE 2050 commitment program, which to date, I just checked yesterday with Mike, has 75 signatory firms who have committed and pledged to work towards net carbon over the next 30 years. And then the ACEEE 2050 database program. So there's another one, Nora, for you and for your slide. This database is collecting project data to inform benchmarks and targets for archetype buildings. So maybe the top of that pyramid there that you were describing. So this group is really capturing the commitment from the workforce and really trying to advance the tools in order to fulfill that commitment. And then finally, the last group that I want to just mention here briefly is building transparency. This group was kind of another spin-off, if you will, from the effort started there at Carbon Leadership. Stacey Smedley and her team are doing an amazing job shepherding these tools and really developing them into programs and platforms that we can all use. The EC3 calculator that Nora talked about, embodied carbon and construction calculator, as well as the Tally platform for whole LCA. Are also being further developed by their team over there, creating a suite of catalog really of the real EPD data, as some of the other speakers have described, are trying to standardize what is collected in those. And they are very strong on the advocacy side as well. So I just wanted to briefly mention these groups that are really working hard in the building sector. If you're not familiar with them, I think you should check them out. Go ahead and join their work. They have a lot of more information on their websites than, of course, I'm able to cover today. I went ahead and put their links in the chat so you guys can grab them and take a look. Okay, next slide, please, Nick. So what we're talking about here during this workshop, perhaps, is what is needed and what is next, kind of teeing up off of the stage that was set by Nora. A mandate is needed. And I think that's what some of them, the other speakers have been describing a little bit earlier. These programs, while fabulous, are voluntary programs. The work is excellent, but it's only incorporated by elite firms, savvy owners, maybe high profile projects. A mandate would level the playing field and require all projects every day to consider embodied carbon impacts and that reduction. And so when a mandate is placed, innovation starts to occur. And that great next leap forward will be achieved through innovation. We really can't continue to do the same old things, the same old ways. We will need that. And without that mandate, there's little incentive to change or innovate. And I have a tiny little story I wanted to share with you all from my experience in the building codes and standard development world. A few cycles ago, there was a requirement for impact resistant glazing to be added to the standard along the hurricane coastline. There was significant pushback from everybody, the industry, the home builders, the owners, that their products don't exist. We can't meet the standard. It will drive up cost of construction, everything. But really from a public safety perspective, this is what was needed. The committee felt strongly. Eventually, the requirements went into the standard and into the building code. And here we sit years later, and we have these products, and it is a level playing field, and really it has improved the resiliency for those projects along the hurricane coastline. So the bigger story is, that the industry really can innovate around this when the playing field is level. And I think that alludes to what Curt was describing earlier in his frustration with some of the other policy that might not have had all that broader input, but to level the playing field, it really moves the market, in my view. Last slide, please, Nick. And so relative to our discussion here, what could, sorry, one back, but that's okay. What could be the mandate? What could be the mandate? It could be from government, like the British Parliament did in the UK, which mandated carbon reductions for that country. I don't necessarily believe that will happen here, but we can be hopeful. A mandate could come from the industry itself, from all of you sitting around the table, as Rachel was just describing. We really want this to go forward. It could come in the form of building codes and standards for construction and operation. In my view, the most effective mandate would be a combination of performance-based requirements, possibly with some prescriptive minimums. We'll see. But mandates for both the design and for the data consistency that Nora was alluding to with the EPA, EPDs, as well as the life cycle assessments for the whole building. And once that innovation is placed, once that mandate is in place, innovation will truly lead the way. I truly believe that. As many of the previous speakers have alluded to, building products as well as design and construction, I would say, are really squeezed. The margins are very thin, and there might not be an appetite or maybe ability to answer the call for improvement if it's not mandated in some capacity. So there is quite a spectrum within the design and construction industry for both product development as well as designers and construction firms, from the smaller ones up to the great big ones that have a global impact and a global reach. And it's difficult for everybody to participate when that's not required. And so one of the points I wanted to highlight is, we don't delegate minimum life safety for the public to those that can afford to do this or those who have the willingness to pursue it. There really is a minimum that we require as a society. And as we start to think forward to this massive challenge that we face here, really, I don't think we need to leave it up to for those to be picking and choosing for who gets to play in that arena. So last slide, please, and this is where I'll end. Obviously, when you make a hammer, everything looks like a nail. And so while incorporating embodied carbon into the standards and building codes might not be the magic bullet, I do think it is certainly part of the solution. So with that, I'm going to go ahead and pass it on to the next speaker. Thanks so much.
Thanks so much, Jennifer. We appreciate it. Now to turn to the architectural perspectives, and we're going to look to Luke Lug with who's fortunately an engineer. I always like to see other engineers on the panels, even though he does work for an architectural and engineering firm. Luke?
Sure. I hope you can hear me. Let me try to put it in presentation mode. So my name is Luke Liang. I have a day job. My day job is to be the Global Sustainable Engineering Studio leader of SOM. I do have a lot of hobbies. One of the hobby is the ACEEE Embodied Carbon Life Cycle Analysis team leader. Why can't we just focus on existing building and not worry about the whole life carbon and embodied carbon? Well, one of the reasons is the world by 2060 will have 2.some billion people more. Okay, so it's almost 30% more population on this world. As a result, United Nations is predicting 2 times more building area by 2060, which is the equivalent to 50% of the carbon emission in building from embodied carbon. In US, we're going to be seeing over 400+ million people, also roughly about 30% increase in population. The point is, we're going to have to build some new buildings. Last year, we saw that United Nations come out saying that we got to accelerate the process to 2040, 1.5 degrees C, code red for humanity because of this population growth and carbon emission problem. So this is the roadmap right now. We're discussing in AIA Large Firm Roundtable with 2030 challenge. The carbon budget, given the y-axis, is not quite, but almost 40 gigatons of carbon. It's about 340 gigatons of carbon equivalent. That's all we have to deal with. So with that, Jennifer mentioned ACEEE 2050, there's AIA 2030, ratchet operating to zero, thinking about 2040, whole life carbon zero future. ACEEE 2050, they were established a little bit before last year, so they are aiming at 2050 carbon zero. And then I also want to bring to your attention of MEP 2040, also with Carbon Leadership Forum. The goal of that is 2030 operating zero, 2040 whole life carbon zero. So that's what we are thinking in terms of our industry, from our architects, structural engineers to MEP engineers. When we think about whole life carbon, in the past, we have been focused on operational, maybe more operational energy. That's changing. So number one on operation is we're gonna have to focus in both energy and carbon. The latest 90.1 Appendix G, which is just came out for public review, include conversion to carbon. So guys, let's focus on both energy and carbon moving forward. Number two, on the operation side, it's going to be about actual performance. There are many codes like Local North Line 97, and there are different cities and locations already coming up with this performance-based standard. I kind of like what Boston is doing. Like what you're seeing on the screen, they establish a roadmap of carbon emission from now till 2050, and it's going to be a little punitive. So you're going to have to perform to that performance and actually carbon to ratchet down to 2050. Now we can discuss whether it should be 2050 or 2040 per the latest IPCC and United Nations finding. So that's the operational side. What about the embodied side? We have just worked on, so right now there's spec section we can use to address the A1 to A3. Basically, is from cradle to gate of manufacturing the embodied carbon. We are developing spec sections to do that. So what we need is data on the whole building carbon. This is like the LATI information of City of London. They are trying to get to 2040 net zero. But what is interesting in City of London is they have the whole building scale embodied carbon information. No matter it's commercial building, residential, school, they establish about 500 to 600 kilogram equivalent CO2 emission per square meter of baseline for today. And they're looking for 100 kilogram carbon dioxide equivalent emission of reduction. So from 500 to 600 reduction to 400 to 500. Not only that, they start developing data to figure out the embodied carbon reduction. How do you get 30% recycle? And how do you get 50% of end of life recycle? So reduce their embodied carbon. Because in the future, by 2030, they want to up those numbers. So your building level target is 300. And then you have 50% of the product coming from recycled material, and end of life is 80% recycle. So you can see, similar to operational carbon, they ratchet down those data. In US, we also need these targets, not just on material scale, but also building scale, just like the CBEX of embodied carbon. We can establish this skyline to ratchet down the embodied carbon to a 2040 net zero future. Finally, those two things I talk about, operational carbon and embodied carbon, they cannot be looked at as silos, because if we do, then it will be just local optimization. It's not a global optimization. For example, I could have very high embodied carbon, but very low operational carbon in a really passive building. Again, I can have really high operational carbon if I have a really low embodied carbon building. The optimum could be somewhere in between. So rather than look at this embodied and operational carbons as silos, what about if we develop a tool that you input the building parameters at one time, like an energy modeling, but it gives you this whole life carbon information to balance the embodied and the operational to give you this optimum goal. Because at the end of the day, carbon molecule is a carbon molecule. It doesn't matter whether it's from embodied carbon or operational carbon. With that, that's my summary of embodied carbon, operational carbon, what we need, and the tool to get to that final optimum. Thank you.
Thank you so much, Luke. Appreciate it. Now, before we go to the panel, we have a short poll up, and Nick's got it up here. And if you want to fill that out as we begin to transition, so the next phase, we're going to have my friend Tom Dower, who brings a lot of experience here, and going to talk from a broad perspective about this, we've been talking about for the last hour. So with that, I will turn it over to Tom Dower.
Thank you, Neil. Hello, everyone. And those were just terrific presentations. I think they all fed together very well. So there, as we can see, there is really growing interest in understanding, measuring, and communicating about the embodied carbon in products, but also the whole life cycle, as Luke was just talking about. And this interest is really driven by consumers, consumer-facing brands, and many of which are making commitments to emissions reductions and which implicate their entire supply chains, and that includes buildings. Huge other drivers in the market are the auto sector, in addition to construction, for example. And it is really interesting for me to see the transitions that are taking place in so many sectors and materials. Each material has a role in society, in quality of life and sustainability, including decarbonization. And as we've heard today, materials producers and purchasers need the tools and incentives to make climate intelligent decisions. I like to say that we should strive to use the right materials in the right applications whenever possible for the lowest carbon and other impacts. Many stakeholders play key roles in this along the life cycle, from design of products and projects with engineers, architects, builders, owners, building occupants, product users, and more. And that's from cradle to grave, or even better, from cradle to cradle. While we're using the term embodied carbon today, we must remember other parts of the life cycle, from design to production to use phase to end of life. This gets to efficient design or material efficiency, design for reuse and recycling, and other topics that you've already heard of today. An important question is how to accelerate carbon reductions from the most impactful sectors as quickly as possible, particularly in countries like the US without a national price on carbon. And the answer is, it's complicated. I recommend technology neutral performance-based policy, letting government set the goals and intentions, but the market driving the innovation and deployment of technologies. And we must ensure policies around procurement, such as Buy Clean, which we've heard today, actually achieve their goal of reducing emissions, not merely shifting delivery and profits to the already cleanest producers of materials, but encouraging real emissions reductions across sectors. It's important to understand that each material, its production methods, and its options for decarbonization can differ quite a lot, and therefore various policies can have different impacts on each material as well. Government cannot solve all the problems and can often get too prescriptive and make mistakes, which can stifle innovation and pick winners and losers. But government policies can be key drivers and enablers of change as well. As we've just heard, government can help with standards and practices around data, transparency, and life cycle assessments, helping small, medium, large manufacturers, as well as working on labeling and consumer protection from fraudulent greenwashing, as well as complementary policies, which I think are really the key, such as tax incentives, grants, loans, loan guarantees, along the RDD and D spectrum. And I'd be interested in hearing more from our panelists on some of those complementary policies as well, and look forward to that discussion. And in the interest of time, I think I'll stop and let us get to the panel. Thanks, Neil.
Fantastic. Thanks, Tom. And we'd like to bring the rest of the panel back up and get a little dialogue going amongst everybody who's been on the session for a while. I think we've had a very spirited discussion over the last hour. Maybe start as we look around the group here and ask the question of, what are the main barriers to reducing embodied carbon that you're observing today in the marketplace? Maybe why don't we start with Rick?
Boy, that's such a big question. Honestly, there are so many barriers. I'm going to point to two main ones, though. One, I think all the panelists would agree with. It's institutional inertia. You have people that have been doing the same thing, the same way, decade upon decade upon decade, and they're in a comfort zone, and they really don't want to get beyond that comfort zone for a variety of reasons. In some cases, it's just, look, it's to get beyond the comfort zone, you've really got to keep up to date and up to speed on all of the innovations and all the different technologies. So I think institutional inertia is one. I would also say, too, there are policy disincentives, unintended consequences of bad policies that are being implemented. So somebody says they've got a great idea, and without calling out any particular state or locality, but they've got a great idea. Hey, let's reduce the carbon by doing X. Okay, the problem is that if you just look at X, you're missing all the other opportunities with, across the entire spectrum. And I think that's part of the problem. We have a lot of policymakers that they're taking a knee-jerk reaction to doing something that seems like a quick win, when in fact, it might actually be counterproductive to what we're all trying to do. I'll stop there.
Fantastic. I see Curt raised his hand. I think he wants to respond back.
Yeah, I guess I would actually kind of flip it around and say that kind of to the contrary. I think industry and the market have moved surprisingly fast in this arena, certainly faster than government. And in many respects, government needs to catch up. I mean, just go back and read sustainability reports from large corporations of 10 years ago, and compare them to the sustainability reports that have been coming out in the past few years, and the ESG commitments that are being made. And I think it's pretty remarkable. So I think industry is kind of rising to the challenge and has set some pretty audacious goals. The challenge now is, I think, to keep their feet to the fire and make sure that those goals are realized over the next decade.
Luke?
Yeah, a couple of quick points here. So number one is accurate embodied carbon data, which we don't have. But, analogy to that, operational energy data, right? We are more comfortable with those data. But ACEEE 90.1 was first put it out on the street in 1970s. So we have decades of experience on that to get to this point that we are comfortable. We are not there with embodied carbon. So what do we need to do? Kind of like what some of you talk about is industry is not easy to change. The margin is low. So what we are doing in ACEEE, we are actually working with ZIPSI. TM65 basically is embodied carbon, MEP, mixed simple. It's like dummy for MEP, embodied carbon. So we kind of create a simple Excel version. They are not perfect, but let's not let perfect get in the way of good, as long as the directional is correct.
Tom?
Thanks, Neil. I just wanted to add, sort of leading off of what Luke just said, in terms of low margins. Another barrier is trade, and the ability of U.S. manufacturers and U.S. materials producers to compete in this environment. And so trade is increasingly becoming a tool within the climate world, right? Looking at carbon adjustments, for example, border adjustments, border mechanisms. And so, making sure that we have the right incentives to help manufacturers do the best they can, which they often do in the United States. Most of our manufacturing is much cleaner than the rest of the world. Building that into the policies and really helping while maintaining that competitiveness can be one of the barriers in a society where we don't have an explicit federal price on carbon, right? And so, competing with fossil-based materials, and there's no direct requirement to reduce emissions yet. So we have to work with the tools we have.
Great. Jennifer.
Thanks, Neil. I kind of following on what Tom said relative to the tools, absolutely. I think we are also missing the mandate. I mean, that was clear from my remarks. Once we level the playing field, then I think more innovation will come to bear on how we solve this problem. But it's hard to be the little guy in a big industry. You just can't. You don't have that ability to compete. And so I think leveling the playing field for the manufacturers, but also the designers and the jurisdictions and the building owners would do great to advance this. That's my 2 cents.
So sort of picking up on that question, how do we work together to fill these gaps that we're talking about here, whether they're data, policy, implementation? How do we do that faster? And maybe I'll start with Rachel. Any thoughts on that?
Absolutely. I speak for the American Wood Council in saying that we would like nothing more than to be shut in a room for a week with our fellow material manufacturers to work some of the details out. A lot of the missing details and data gaps have been articulated well throughout this process, where industry does move at a different pace than government. So there's opportunity in getting us together at the table and telling us that, we need solutions and we need some of this figured out methodologically. What are the data gaps, et cetera, et cetera. Right now, from our experience, and I think it's shared with others, we are begging for seats at the table, or we're involved at the point a bill is dropped. Having worked in policy for many, many years, there is a lot of opportunity to collaborate before a bill is written. And, I think that is really where we are hungry for engagement, both as AWC and with our other materials.
Yeah. Luke?
Yeah, I think one of the key here is the disclosure of data for both material level embodied carbon and building level embodied carbon. Kind of like the CBEX on operational. So we start sharing those information and inform the decision. Case in the point, City of London or the latest Canadian cities, they create this database of building. Now, if you look at that Canadian report, in that report, the Canadian buildings, roughly their embodied carbon without MEP is about 400 to 500 kilogram per CO2 equivalent per square meter. So it starts informing that process if we can start sharing those data. Another piece in there that we didn't think about a lot, but also important, refrigerant. Last year in the GSA portfolio, 15% of the emission is actually from refrigerant. So that sort of data can help us to inform the direction and make informed decisions.
Well, that actually poses a really great sort of follow-on question, Luke, for the group is, where do we need to focus first? I mean, what are the key questions? There's so much that needs to be done. We can't do everything at the same time. Thoughts on that? So Rachel.
I think that Nora's presentation and the research that she did actually addresses a lot of this. We're being asked to participate in the data landscape without harmonization of the systems being used to manage that data. It gets to what Luke was saying as well with regard to let's make sure that the data is transparent, accurate. What I think it was Rick or Curt was saying with regard to apples, a lot of that foundational data work has simply not been done. How different materials are treated within each of these systems is different. And therefore, if you're doing a whole building LCA, it's impossible to actually see what will give you, what will maximize your embodied carbon reductions by virtue of the fact that the materials aren't necessarily apples to apples comparison. So to me, there is a lot of groundwork, you know, folks rushed in the recognition that, oh, folks being policymakers rushed in the recognition that there was a lot of opportunity for addressing climate change through the built environment. But I think that we still need a bit of a more metered and thoughtful approach to making sure the foundational data that's utilized in these efforts is harmonized, is accurate, is transparent, is publicly available, is not essentially being then changed through proprietary equations, etc. There's a lot of, you know, data work that was still necessary before we dove into some of the more global policies. I'm seeing heads shaking, and that always makes me feel good.
So Rick?
Yeah, I just want to echo what Rachel said, because the consequence of that, because there is no uniform system, is that you have not just 50 different states, but you have hundreds of different communities that are going their own way. And what we tend to see is that it becomes almost, you know, pardon the pun, but almost a limbo contest. How low can you go? Well, look, again, when you just focus on one aspect, you're really losing, you know, sight of everything else that could contribute. And I think that's a really, it's a dangerous road to go down. And by the way, you know, the other unintended consequence is, look, it's just like, you know, for those of us that maybe have a gasoline car, if we're going to buy gas, we look at, hey, if I can go to that county and they don't have that 5 cents, you know, gallon tax, I'll drive over there. Well, guess what? That's how building developers and property managers and others think. So that the point is, again, to Rachel's point, without some uniformity, really all we're doing is, you know, pushing efforts away, and we're doing ourselves a disservice, I think.
Tom?
Yeah, so I would just also like to add that while there is a lot of work happening on data and transparency in systems, but to your question, Neil, about where we should focus first, my money is on the most impactful things being deploying technologies today to lower carbon footprint of each material. And they all have different solutions. Every speaker here comes from a different part of the supply chain, and particularly the materials producers. And as everyone knows, there's tons of DOE programs that can accelerate deployment to reduce emissions faster while we build those systems that can measure better. But there is no doubt that if we can find those solutions to reducing the emissions from steel, cement, fiberglass, insulation, wood, you name it, they all, again, they're coming from very different chemistries and product cycles. But if we can do that today, the benefits will accrue to the atmosphere, which is what we were talking about, while we get those measurements and data in place in those systems.
Okay, Jennifer, why don't I turn to you, and then we'll wrap up with Luke.
Okay, thank you, Neil. Kind of want to piggyback again on what Tom was saying. I like this that he goes first and tees it up for me, and then I can hit the softball. But I totally agree with a lot of what has been said. In the process of standardization, the process of building code development is I continue to use the word robust. There are so many stakeholders at that table. I have your counterparts, Rachel, and your counterparts, Rick. Curt, I don't have any of yours, so send them on over. But for sure, the other folks are all in the room. It's a very big tent. And to get all of the stakeholders present, you come out with a consensus document. It doesn't mean that everybody is super duper happy at the end, but we can all live with what's going forward. And I would just like to put a very fine point on the end that these things develop over time. we're talking about the documents that I developed that govern how buildings are designed for the natural hazards, for wind, earthquake, snow, all of these things, the picture that I showed that go into the building code, those take 5-6 years to develop. Takes another 2-3 years to get them adopted into the building code. Takes another couple of years for that to get adopted at the jurisdiction level. So if we're talking about we start today, we don't actually see results coming out the other side that can be implemented by a jurisdiction through a building code process for a decade. So if we're trying to reach 2050 targets, we absolutely need to start today. What that looks like kind of means we don't have all the answers right now, but we need to start down a path and bring the whole stakeholder group with us, and then those innovations will start rolling. That's my soapbox, but I'll hop off for now. Luke, chime in.
Well,
No.
yeah, go for it, Luke.
Yeah, no, I totally agree with what everybody said just now. Is that standard is important, but the good news there is there are convergent towards that. For example, in the EN 15978, oftentimes people now focus on A1 to A3, sometimes it's A1 to A5, which is majority of the carbon where it's generated in terms of embodied carbon, to your question. So the idea of focus, now that we start knowing that and using that sort of framework, we start understanding A1 to A3 to maybe A4 and A5, could be up to 80-90% of that whole embodied carbon emission, number one. Number two is on the building side, the structure is going to be very important. And then one of the highest GWP, global warming potential in terms of material, is actually refrigerant. So that's something that we definitely need to think about it too.
Okay, well, we're running out of time. I appreciate everybody. This has been a fabulous panel, lots of tremendous information. We're going to put a final poll up on sort of what are the most important issues that you see up there. And while we do, I'll bring my colleague Ed Ryder up for some closing remarks.
Okay, thanks, Neil. While folks are putting their data in, I'd like to thank all speakers that brought up just, gosh, a large number of points. I'll highlight a couple. One is engagement. And I think we heard from Jennifer that the tent is large and all are invited into the tent. So engagement is certainly crucial to create that level playing field and understand what that means across the entire community. Equivalencies, we heard that not only tool sets need to be further developed to incorporate more of the different codes that Nora had talked about completely from cradle all the way to the grave, but we also heard about the need for design for recycling and design for end of life, which I think is also part of the story. So I think we've got a launch here. We've started the discussion. And now the important phase is to continue the discussion into the next areas of learning so that we can get a start. Getting a start is super important and not waiting to have everything all perfectly right before we start down that path. But if we use an agile approach and learn quickly as we go, and if we share the information so that all can learn quickly, that would be to our great advantage. With that, Neil, my closing comments, I'll hand it back to you.
Ed, thank you. And again, thanks to all of the panelists today and to my colleagues at ACEEE. A couple of quick housekeeping notes. As we said at the beginning, we were recording this session, and that recording will go into some post-production here in the next day or so. And we hope to have that posted. And with that, we will also post the slides from all the speakers out there. Apologies to anybody who did not get their questions answered here. We encourage you to reach out to the ACEEE team and the panelists if you want to continue this dialogue. We certainly plan to continue this dialogue at ACEEE going forward and anticipate a couple of meetings following up on key topics of greatest interest to this group. again, appreciation in particular to both Nick Roper and Pavitra Srinivasan for their help in actually organizing this. It's the people who you don't see on camera who actually make this possible. And with that, on behalf of ACEEE and everybody else, I want to say thank you very much for your participation and look forward to continuing this dialogue going forward.